starting chapter 13 today, and it is called Fluid Dynamics. So what does the word dynamics mean? Moving. So if I put these two words together, what do they mean?
Fluid motion.
There we go. And what do we mean by fluids? Liquids and gases, right?
Anything that's not a solid.
Anything that's not a solid, anything that has a tendency to flow, right, is called a fluid. So liquids, gases, we can make them flow in different things. The other thing that when we talk about dynamics that we talked when we did Newtonian was, number one, we talked about a particle, and number two, we talked about forces that impact those motions. So the number two things, one is movement, number two are forces that cause that motion. When fluids flow, what are the forces that cause these motions? So when we were doing Newtonian mechanics, we did dynamics there too, and we talked about forces, force applied, gravity, friction, all of those forces. In this case, we're going to do all the same things, except we're going to deal with them when we're dealing with fluids. That's the only difference. So all the things keep in mind. So we will talk about velocities, we will talk about forces, we will talk about friction, we will talk about all kinds of different things, but in terms of fluids. Another field of study that engineers, civil, mechanical, biomedical, all those fields, environmental, right, people have to face are water. So a lot of time is spent studying water dynamics. And when we study water, the flow of, or how to make it go through a pipe, or how to make it go through a river, how to build a dam, how to build a reservoir, how to build a water tower, that particular kind of fluid study is also called hydrostatics. So I want you to be aware of these differences. When we study any fluid, it's called fluid dynamics. When we particularly study water and its characteristics, that is called hydrodynamics or hydrostatics. So fluid, when it is water under consideration, is called hydrodynamics. Why is that important? Look at history. Where were all big civilizations formed?
Near one. Near rivers.
Near rivers, near water. Not necessarily near oceans, but near waters that had a flow to them. Why was that essential? Because water is so essential to human beings, right? You need them to drink. You need water to wash your clothes, wash your dishes, irrigate the fields, build crops, everything. So every single civilization, go back in history, thousands and thousands of years, were built on the backs of rivers, right? Every single one. You can go anywhere in the world and find a river and find a great civilization that was built right next to it, right? So the study of water is very, very important. We not only need to study it to survive, but we also need because all the issues that come with the water flow. So for example, where there is a river, there will be a flood. So you have to account for that. And rivers over time turn. I don't know if you've ever heard that phrase, right? The river turns. And the civilizations, nowadays, we have ways, engineers, civil, environmental, that actually help us bind the rivers to where we want them to go. But in previous times, what would happen is generations ago, when the river turned, people moved, right? So as soon as the river would turn, the civilization would pick up their stuff and move to another place because people had no way to make sure that the river did what you wanted to do. Now we don't have those problems. but the study of the river flow is very important. So hydrodynamics basically deals with two fundamental things. One, it deals with what are called open channels, and two, where we deal with closed channels. Based on our discussion just now, can anyone predict what an open channel is?
One where water is free.
Which would be rivers and streams, right? Anything where water flows. Whereas what would be a closed channel?
A lake.
Not really.
Bucket.
True, but a channel would probably be a pipe where there is a boundary, right? A particular boundary. Usually think of it like a man-made thing scenario. So if it's a man-made scenario, we call it like a closed channel. We kind of think of it like, okay, how do I get water from the river to my third floor? How do I construct a water tower where water flows in a certain direction? So fundamentally, open channels are rivers, streams, lakes, where there is not a particular boundary. But a closed channel is where the boundary is rigid and doesn't move, which doesn't mean like it has to be hard. It could be like your pipe, the one garden hose, right? You can change it, but the boundary is rigid. Hopefully none of the water is leaking out of your boundary.
Right.
But it doesn't mean it has to be like, don't think of it like a rigid something, right? A pipe. It could be bendable, but it still has to have a boundary. Okay, so an open channel would be defined as the ones where there are like rivers, streams, where there's not a particularly rigid boundary, whereas closed channels will be pipes. Another way of defining them could be the flow is not always in contact with the boundary. Whereas this one, flow always considered in contact with boundary. So open channels are generally driven by gravity only. The river flows where gravity takes it. Whereas this one, they are not only driven by gravity, but also pressure, which includes maybe density of the fluid you're trying to move. And it also could include the height. So think of water pipes. You can only raise them a certain height, right?